Hello, everyone. Good afternoon. Nice to meet you again. So yesterday we started our on time series forecasting. We briefly discussed about time series forecasting, and I have tried to outline its significance in our daily life activities. And we have also discussed about the characteristics of time series forecasting, such as seasonality, themes, abrupt changes, and some other characteristics of time series forecasting, like seasonal. Like apart from seasonality, I discuss about constant covariance, which we sometimes call stationarity, as I have mentioned in my previous lecture, that mostly when time series data has some seasonalities or trends, it will be very difficult for us to use it. Sometimes we employ some techniques like seasonal decompose so that we can change the format of our data so that it can be a stationary data, which means that it has a constant variance. So yesterday, we started our practical in time series forecasting with simple statistical model, that is ARIMA model. Autoregressive integrated moving average. This is what ARIMA stands for. So unfortunately, in the last segment, while running the last code segment, I tried to run after we evaluated our model to compare actual and predicted values. Unfortunately, I encountered some errors, which I don't know from where it is. And successfully, I restarted running the program again because I tried to find where the error is and it works again. So this is what I'm trying to show yesterday. If you look at this chart, you can see that our CO2 forecast, there is a wide margin or a wide gap between actual and predicted values of CO2, that is carbon dioxide.
Excuse me a bit, Doctor. Is it possible to zoom in a bit? It looks a bit small. Can you zoom in a bit? Is it possible?
What of now?
No, it's even smaller.
It's even smaller. Let me try. Because it is a workstation, so it is a big screen. Let me try from my Zoom to see.
I think if you press Control plus, maybe it increases it. Can you try Control and plus or Command prompt?
Let me try from Zoom. Let me try. What of now?
Yeah, it's getting a bit bigger.
It's getting bigger.
Yeah,
is it visible? Is it visible?
Lukman, can you see? Maybe my eyes are not too good. Lukman, you can unmute yourself. Can you see?
Is it visible? Or let me check from the comment. Okay, sorry. Is it visible now?
To me, it's still small, but I want some other people to make their own comments. Maybe it's my...
A bit small. It's a bit small.
I think if you press Control and plus at the same time, it increases. It will zoom.
Okay. Okay, let me do it.
Control and plus sign on the keyboard.
What of now? I have pressed. What of now? Is it visible?
Or probably you need to stop sharing, increase the font and the share again. Maybe that's why the command key doesn't work. You can stop sharing. Yeah, then you press Control plus. If it's bigger, then you share again.
Okay, let me share again. What of now? Is it the same thing? Or there is an improvement?
I don't think there's any improvement actually.
Oh, sorry. Sorry. Is there any now? Is there any improvement, doctor?
Not that I have seen.
So finally, oh my God.
But it was visible yesterday, sir.
Yeah, it was. It is the same PC I'm using. I don't know what actually happened, and I didn't touch anything on my PC setting. It is my work because I'm working on my workstation. I'm using my workstation. What happened?
Recording in progress.
Is it okay now? Is it visible? Is it visible now?
I think we can just, it's small, but I think we can just manage.
Okay.
You can, if you are using computer, you can barely see it. If you are using mobile phone, you need to zoom, otherwise you cannot see anything.
Exactly.
Okay. May I continue, Doctor?
But yeah, we'll just go ahead, continue.
So, as I mentioned earlier, after we finish evaluating our model, right from the results we got from our model, building 4 evaluation metrics: mean squared error, mean absolute error, root mean squared error, and even R squared, which is, its range is supposed to be from 0 to 9. If you look at it, we are even getting negative values, and the remaining evaluation metrics, the value is very high. More especially for error, we have about 200 attributes. This means, and if you look at this diagram, which is this chart, you can see that if you look at this chart, you can see that the actual versus predicted values is, the margin is very wide. This means that our forecast is totally incorrect. So this means that our model didn't learn anything from our data. Our model failed to understand the complex pattern of our data, that is our CO2 data set. So now, how can we try to improve the model? Sometimes we can use the default hyperparameters of the model without trying to fine tune so that we can improve the performance of our model. Sometimes it may work, and sometimes it may not, because maybe that model is not suitable for that data set. It happens sometimes. So now let us look at how we can try to improve the performance of our ARIMA model. As in the previous one, I mean in the previous practical which we did yesterday, I started by importing the important libraries. So these are the necessary libraries that we need. So unlike in the previous practical, now we imported grid-start CB, and from sklearn base, we imported base estimator and regressor mixing. So as in the previous, we did create our data frame, which you are familiar with, because today we have about 3, if possible. Apart from this one, we will discuss about 2 more algorithms. So then as in this previous one, I have now set our our 3 columns, year and month, as index of our data frame. And I have now created another data frame by using CO2. Now, and I use window size of 2, because the reason why I'm using this window size of 2, I've already shared, I will later share the link of my GitHub with you so that you can download the entire repository. You can clone or download, depending if you have a GitHub account, you can easily clone the repository. So now, for just to learn, I have used window size of 2. If you like, you can increase the window size. So now I'm now applying sliding window. We have created list of predictions and actual values. And I have used for loop. As in the previous, now we take our train window and we take our data frames, and instead of using like sometimes in machine learning, we can just simply use train test split to split our data set, to partition our data set, and sometimes we can use slicing technique, which I know you are familiar with, since time series forecasting is the 7th among the topics you have covered so far in machine learning. You are not new to machine learning. So what we are now trying to, as in the previous one, we have now created our model, ARIMA model. We have now created our model, ARIMA model, using train window. As we will try to compare our predicted values with our focus, which is an instance of our model, the fit. Because model fit is an instance of our model that we created. A model is post ARIMA, train window, order of 100. So now the next thing, so we will now run grid search CV once we finish with this.
I think we missed you a bit. I can't.
Pardon? Yeah. Okay. So now the next thing is setting our hyperparameters. So we now use the one class from ARIMA called ARIMA wrap. We now created, inside our class, we are wrapping best estimator and regressor mixing. So this is a class we created called ARIMA wrap. So the next thing, as I have mentioned earlier, in time series forecasting, since we are dealing now with univariate time series forecasting approach, in univariate time series forecasting approach, we are trying to predict, we are trying to use the previous values of our historical data to predict the future values. What we are doing, it is the same historical data, but we can partition that historical data into training and test set, or if we like, we even divide it into 3: training, training, validation, and test sets. So in this case, we are dividing our data, or we are splitting our data of our CO2 data into training and test sets. So it is from the same CO2 data set. So now we have already set up our grid sat CV hyperparameter tuning. So the next thing is to check our X and Y, which Y is for our training set, and I mean X for training and Y for test sets. Then now let us initiate our ARIMA model. And we use mean squared, I use mean squared error. In this regard, we use mean squared error as our evaluation metrics. So now the next thing is to find the best parameters, as you all know about. I know you know much about hyperparameter tuning, since you have covered a lot of classes in machine learning. So we are now getting the best parameters, and the next thing is to update our model with the best parameters. After we updated our model with the best parameters, now is to generate predictions using the best models that we have that we get from GridSat-C. So after we finish our training, now after we finish our hyperparameter tuning, now we need to split our data now into training and test, and train it with the best hyperparameters that we got from GridSat-C. So after we train and test our model, so now training the best model on training set. Now we are training the model on the training set. And now we are now making predictions. Okay. So the next thing is to try to evaluate our model using 4 evaluation metrics. So we now, unlike in the previous, we just evaluate the entire model. But in this case, I try to evaluate the training pace and test pace. So we will now try to compare our model performance at the training pace and at the test pace. So now if you look at this, at the training pace, we have MAE of 4.2422, and at the test set, we have MAE of 9.7989. MSE, we have 25 at the training pace, and we have 101.8 at the test pace. And the R squared, root mean squared errors, RMSE, we have 5, and as the test pace, we have 10. And the R squared, we have minus 0.007, while in the R squared value in test space, we have minus 7.378. So in a nutshell, as you can see, when we compare these values of from the previous experiment of our ARIMA model without hyperparameter tuning, you can see that the model performance has improved significantly. But with that, looking at the R squared values, you can see that, and if you look at the errors, although the margin between training pace and test pace is quite high, you can say that the training pace values are lower when compared to the test pace, because our model is familiar with the training data. So we expect our training evaluation, the errors from the training phase, to be lower, because our model is familiar with the training set, while it's not familiar with the test sets. So if you look at the test space, when you compare the 4 evaluation metrics, their correspondence from training to test space, you can realize that the test space has higher values when compared to the training phase. So if you look at this, values that we got from the previous experiment, we have mean squared errors was 203. Mean absolute error was 13.6, and I think here it is. Here it is. So these are the evaluations, these are the values that we get. So looking at this, we can conclude that ARIMA model is not good, because sometimes you may try your level base, you may try to scale your data, you may try to incorporate different data pre-processing techniques, because in machine learning, if you didn't do data pre-processing very well, you cannot expect your model to perform very well. So at some point, even if you employ good techniques for data pre-processing, sometimes your model may not perform very well because the model is not suitable for that data set. I think this is what happened. ARIMA model is not suitable for this type of data set. Now, let us look at SBR, support vector regression, or the SBM that you know that we have used, that you have used previously, SBM, support vector machine. So support vector machine is used in classification, while support vector regression is a variant of SB which is used in time series, forecasting. So now let us look at SBM. As in the previous experiment, we have to start always with importing the necessary libraries that will enable us to build our model. So as in the case of classification, instead of SBR, we are not importing SBR instead, in case of classification, but in case of regression, we are SBR. The next thing is to create a data frame, and at this point, we are now setting our so now we are now setting our index year, and month. We are now setting them as at the index of our data set. I mean, of our data frame. So now let us generate training samples and targets. So as I have mentioned, we are now using X and Y. X and Y, X stands for the features as we are doing in machine learning, or the train set, and Y for the targets, which is the test set. In this case, in this regard, because we are dealing with only one column. In a situation where this is our target, this is X is for the features, and Y is for the target. X is for the features and Y is for the target. So, but in this case, we have only one column or only one variable. We are taking some part as target and some part as features. We have now taken this size. We are now using window size. So the next thing is to split our data set into training and test set, into 80% for training and 20% for test. If you like, you can try to change sometimes 70 for training and 30 for testing, or sometimes 70 for training, 10 for testing, 10 for validation, and 20 for test, depending on the way. So now we are now creating our model. We have now created our support vector regression. So SBM is used in classification tasks, as I mentioned earlier, which aim to find the optimal hyperplanes that maximally separate data points of different classes. So if you have a classification task, either it is binary classification or multi-class classification, you can employ SBN. But in case of regression, where you are not dealing with discrete values, you are dealing with continuous values. Like in our own case here, our data consists of continuous values. So we have to use, it is a regression problem. Whenever your target has a continuous values, so you have to consider that as regression problem, because our target, in case of multivariate time series forecasting, whereby your target depends on two or more variables. So in a situation whereby you have many or multiple features in your time series forecasting, we call that time series forecasting, because a single dependent variable depends on different variables. So in that case, we call it multivariate time series forecasting. But in this case, we are working on univariate time series forecasting, because we have 233. So now we train our model. We're using X train, Y train. So the next thing is to make forecasts. We are making forecasting using our widespread train model.predict X train, widespread test model.predict X test. So now we have now trained our model and test our model at the same time. So the next thing is to evaluate our model. So to evaluate our model, I have used 3 evaluation metrics: MSE, MAE, and RMSE. So now you can see that the errors we got from this model is very low. More especially if you look at the training set metrics, they are very low. We have 1.8 for MSE, 1.04 for MAE, mean absolute error, and 1.35 for root mean squared error for the training set metrics, evaluation metrics at the training period. So for the test phase, we have 32 for MSE, 4.89 for MAE, and 5.7 for RMSE. So even by mere looking at this value, you can see that the error is very low. Although in case of these 3 evaluation metrics, unlike in case of R square, where you have a range from 0 to 9, you can easily evaluate a model. But in case of MSE, MAE, and RMSE, sometimes you cannot heavily rely on the values you get. Sometimes you have to try to compare the actual values, the actual with the predicted values. But by mere looking at this, we can say that our model performed very well when compared to ARIMA model, which means that our SBR is more suitable for this task when compared to ARIMA model. Even with hyperparameter tuning, we failed to achieve a good forecast result with ARIMA model. So now the next thing is to compare the actual and predicted values. So now if you look at this, you can see that the actual and predicted CO2 levels, you can see that at some point they are closer, at some point they are the same wall, at some point, more especially at the initial state. And one of the reasons why we achieve this is that we use smaller window size. If let's say you try to use in time series forecasting, the more you increase the window size, the less focus accuracy you may have. Your model will perform very well with lower window size, and it performs worse with higher window size. So more especially if we are dealing with focus horizon, as I've mentioned earlier, like we have in time series forecasting, we can use lookbacks or sliding window, whereby at the end of the day, if you are using sliding window, you are predicting the only one value at a time. But in case of focused horizon, you can specify the number of values that you want to forecast ahead or in future. So as you increase the focus horizon, so the efficacy or the accuracy of your model will start to deteriorate, or it will start to decrease. So the lower focus horizon, if the model performs very well, you will realize that at lower focus horizon, the model performs very well. But at higher focus horizon ahead, it may perform a little bit lower when you compare with the lower focus horizon. So if you look at this, you can see that it is this means that SBM is good for our focus problem of CO2 levels focus, because there is at some point they have the same, they reach equilibrium whereby the actual and predicted values have the same values, while at some point they diverge, whereby at some point you can see that the value of the predicted is a little bit higher than the actual, and at some point it is lower. So these are the three scenarios that you may find when you are doing forecast. And one of you also, I maybe join our class late, because you are also, I tried to explain to him. Let me explain again. Time is the application of time series forecasting. Time series forecasting is very applicable. Let me give you an example of aviation sector. Aviation sector cannot work with time series forecasting because they heavily rely on weather forecasting. If you look at it, aviation sector heavily rely on time series forecasting. So if there is no weather forecast, if there is no weather forecasting tools or machines that they are using for forecasting, so airline will not take off. So from the takeoff to the landing on any airplane or aeroplane, they heavily rely on weather forecasting, because they are trying to find the shortest route. And at some point, even if it is sky, so sometimes they have to change their route due to the bad weather, because they are predicting this is what will happen on the social route. So sometimes even if it is on the sky, so they have to change their route. So like me also, if you take an example of what I am doing in my PhD, what I'm doing in my PhD is focus more on ocean and coastal conditions forecasting. If you look at the shipping, if you look at the maritime sector, so maritime sector like shipping, most of the importation and exportation, they heavily rely on cargo ships as the means of transporting their goods. So without good forecasting, without good weather forecasting, or without good ocean conditions forecasting, so the ships may end up capsizing, because there may be a situation where they may experience a storm, that is a high wave storm surge, which is a very high wave. So without forecasting, so the ship may end up capsizing, which will definitely incur loss of life and that of property as well. So now we don't have much time. Let me quickly go to linear regression, forecasting using linear regression. So now our next topic is linear regression. Although I have a cross validation function, cross validation using SBM. Although SBM performed very well, but for practice, you may try to run this notebook, which I have already referred for hyperparameter tuning. If let's say you are trying to see how can we try to improve the performance of SBM. So you may try to run this notebook, because looking at our time, we don't have much time. So I will share my GitHub repository link with you so that you can clone it on your system. So the next one is linear regression, linear model. So we are from skline linear model, we are importing linear regression. And in this case, instead of the manual slicing, I will use trend test split. So while the remaining libraries imported that I have used, that I have imported, you are familiar with. This is our data frame. Also, this is just a technique I have added in case where you have a missing value. Sometimes we have different techniques. So, but sometimes we employ this drop any. If you have any data point which is not available, you can employ this. But in our own case, our data is very small. It has 161 data points, so it is very small, and there is no any missing values. So I just introduce this technique so that in case where you have a missing value, so as part of data pre-processing. So I have now set this as in the previous, I have now set this as in the previous. So now I introduce what we call lag. That is what we call lag in time series forecasting. Sometimes we use sliding windows, look back, lags. So in a nutshell, you can say in time series forecasting, lags, look backs, or window size or sliding windows, they are almost the same. Mostly in traditional statistics, they mostly use lags in traditional statistics instead of sliding windows or look back. Most of the times they use this term lag. And inshallah, at the end of this course, I will try to recommend, I will share the link with you, one course from Kaggle. They have time series forecasting course. So if you want to expand your knowledge in time series forecasting, it is a good course so that you can expand your knowledge in time series forecasting, because in 2 days or I can say in 2 hours, we cannot be able to cover much, even the foundation. All what I try to do is to give you, to lay a foundation for you in time series forecasting. So if you want to expand your knowledge, you can start as a starter from that Kaggle time series forecasting certification. Then from there, you can continue your journey in time series forecasting. So now we are using lag features as a sliding window of tree. So now if you look at this, I split the data into training and test set. In the training set, I have lag 1, COT lag 1, COT lag 2, and CO2 lag 3. So as I have mentioned earlier, sometimes I introduce these techniques for data pre-processing. I have told you that if you are doing machine learning, sometimes you need to spend a lot of time in data pre-processing, because without proper data pre-processing, no matter how we try, your model will not perform very well. The next thing is to use train set split. If you like, you can shuffle your data set, but in this case, we don't need to shuffle our data. We don't need to shuffle our data set, because we want to maintain that sequence. We want to maintain our sequence, time series sequence. So now we created our model from linear regression, and we train our model that fit X train, Y train. And the next thing is to train our auto regression model, linear regression model. Oh, I did the same thing. Oh, I have did it twice, sorry. I did it twice. So you can remove it. So the next thing is to make predictions. So y free train is equal to model.predict x train. Then we test our model, y free test model.predicts x test. So now we make a prediction on the train set and test our model using x. So now we evaluate our model. So looking at this, you can see that from the training set, we have MSE of 1.0, but in the test set, we have 0.8. In the training set, we have 0.717, and in the test set, we have 0.7. So also the training, root mean squared error from the training, we have 1.0, and from the test, we have 0.8. So in this case, is our model overfitting or underfitting? So in this case, our model is underfitting or overfitting. Like in our previous, you can see that in our previous case of ARIMA model, in the first model, which we discussed with you, the model is overfitting. But if you look at the SBM, in the case of SBM, our model performed very well. And the familiarity with the data, with the training set makes our model training evaluation to be lower than the test set. But in this case, you can see that the test evaluation are higher than the training evaluation. So is our model underfitting or overfitting? You have an idea about model overfitting and reaching an optimal. So now it will be a question and answer. So Dr. Ibrahim, okay, who is the host?
Thank you.
Okay. So do you have any other question, please? So this is the end of our today's lecture regarding time, because we don't have much time, because in 2 sessions we cannot be able to cover the most, we cannot be, but at least I have tried my best to try to give you the basics knowledge in time series forecasting. I know you are not new to machine learning, so you can go on your journey on your own. At least I have laid a foundation. I gave you the foundation in time series forecasting. So if you have any question, you are free to ask.
Okay, thank you, sir, for the presentation, for the rich presentation over yesterday and today. So I wanted to ask a question regarding the models that you use for the time series.
Okay.
Okay, so while there was a time Prof. Andrew NG spoke about not using support vector machines because they mostly do anything that he can do with SVM, whether classification or regression. He can do the same thing with neural networks. So I just wanted to ask whether that applies to time series, the way you did with SVR today.
Yeah. Can you please repeat your question again, because there is some noise here? Let me reduce. Can you repeat your question?
So my question is, there is Prof. Andrew NG is of the opinion that
Coursera.
Yeah, he's of the opinion. Yes, he's of the opinion that anything you do use support vector with, whether regression or classification, he no longer teaches it because you can use neural networks to achieve anything you want with SV support vector. So I wanted to know whether it applies to time series, what you taught us today, or whether it's...
Okay, I understand your question. The issue is that when you are teaching, maybe for you, you have gone far, because this is a machine learning, data science class. So whenever you want to start teaching, if you look at it, we start with the most basics one, which is ARIMA model. You understand? We started with the most basic one, which is ARIMA model. Apart from ARIMA model, we have like Facebook Prophet is also a time series forecasting algorithm. But from the basic one, ARIMA model, which has been used for a quite long period of time, we shifted to machine learning algorithms. Nowadays, when we are talking about time series forecasting. Now our focus is this three. Either LST, like recurrent neural network was the ones that dominated the world of time series forecasting. Then later, long short time memory, that is LSTM, GRU, which is another variant of recurrent neural network, because LSTM and GRU, that is gated recurrent unit, they are the variants of recurrent neural network. Then later, nowadays, we have transformer models, which are now we have which there are so many large language models that are built based on transformer models that we can use in our time series forecasting tasks. So at the basic level, we cannot start with ANN, although maybe for you, you have already started. But when you want to start teaching time series forecasting, you have to lay a foundation. You understand? Then from here, you can go further. You can go up to using transformer in time series forecasting. The sky is your limit. But what I'm trying to do is to give you just the basics knowledge you need in time series forecasting. Sometimes, like ANN, sometimes it's not that much good, to be honest, in case of time series forecasting, because ANN is more, because in time series forecasting, most times we are focusing more on temporal dependencies of data. Our focus is more on temporal dependencies, while ANN is more good as capturing the complex spatial dependencies. So ANN is good at capturing the spatial dependencies in time series. So that is why at advanced level, when we are talking about time series forecasting, we are starting from RNN, LSTM, GRU, and now different variants of transformer models. I hope I answered your question. So yes, the next question, okay. Okay, good day. Does ARIMA model account for unexplained, that is non-stationary occurrences? So like any other time series forecasting model, ARIMA model, after ARIMA model was introduced, there are some other models that was also introduced. Like there is what you call SARIMAT. It's also a variant of ARIMA. So if you look at ARIMA model, it's designed to capture and focus pattern in stationary time series data. That is why I have mentioned that sometimes if you are working more especially with ARIMA model, sometimes we have to employ what we call seasonal decompose from start model library. Because if the data is not stationary data, so sometimes we find it very difficult to work with ARIMA model. As I've told you, mostly nowadays, we are using ARIMA models sometimes for practice only, because as it is now, we have different machine learning and deep learning models, starting from regression. You can also, like, in case of machine learning, in case of time series forecasting with machine learning, you can also employ other techniques like ensemble methods, or bagging or ensemble method, bagging or boosting. You can employ any in order to improve your model performance. At advanced level, we are using this LSTM, GRU, transformers. These are the latest algorithm or techniques we are using in time series process. So we have 4 minutes. Do you have any other question? Let me share my GitHub link so that you can be able. So you can download from this. So the repository of these files is there. So we are not unable to complete the last file because we don't have much time. We have only 1 hour. So if you have any question, let me share my email with you. So in case you need any help related to time series forecasting, so here is my email. You can contact me via this email. So do you have any other question? So in the absence of question, I think we can call it a day. Is there any other question? Because we still have three more minutes to close this session. I've already shared the GitHub link with, okay. Next time, because I have, for some reasons, I have uninstalled my Telegram. So I'm very sorry. If any one of you, or maybe I will share with your colleague, I think, who is the host, I will inform him to share with you. Okay, so no problem. I will share the link with him so that you can share it with you via Telegram. Okay, no problem, because I have already installed my Telegram for some reasons. So I can literally say I'm offline on Telegram. For now, I'm offline. No, 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 no. You cannot determine the best by observation. The only thing you can do is that from the types of data set, after there is what we call explanatory data analysis, because if you look at it, we have only 2 sessions for this, so we cannot go deeper. And I think you have an idea about explanatory data analysis, whereby if you can do explanatory data analysis, you can easily find all this what we have discussed so far in our classes. Like you can try to find the pattern of your data, whether your data has some seasonality, trends, or what have you. And I have also, let me share this as I have mentioned, Kaggle time series forecasting, I've forgotten. Kaggle time series forecasting class. So from mere looking, you can just find out some trends, seasonality in your data, but you cannot, you have to try the different models. But the ones that we have used, you can say when we are talking about time series forecasting, they are the basics ones. Now, mostly now, if we are talking about time series forecasting, as I have mentioned, our focus is using LSTMs. They are very good long short-term memory, gated recurrent RNN, recurrent neural network, and nowadays transformers. So these are the ones that we are using mostly. But at the basic level, you can try to. But if there are some people that depending on the type of data that you have, because I have one experience, because there are some data with spatial-temporal dependencies. So if it has high spatial dependency, then temporal dependency. In some cases, we may realize that like linear regression, I run one experiment in which I realized that linear regression, I use linear regression, and autoregression outperform LSTM. In some cases, depending on how you pre-process your data, which includes scaling and other things, or maybe, so depending on the way you work on your model. But in most cases, so this is the link for, if you want to expand your knowledge in time series forecasting, so you can take this course. I think is it 4 or 6 hours in total? So you can try this course. You can try this course. Okay. Now it is 2 minutes past 2. Do you have any other question, or we can just close our today's session? Because I think we have. So in the absence of questions, and we have already reached the threshold of our today's session. So we can call it a day. Okay, so thank you very much for having me and your maximum cooperation. Okay, have a nice.